Okay, so here we've got a ratio in a practical context. We know that the ratio of men to women is 5 to 3, but that women to children was 7 to 4. So the first thing I might do is do a little bit of colour coding with this. So first of all, I've got the men being 5 and the women being 3, but in this second ratio, the women are 7 parts compared to the children, which are 4. Now, the only way that we can compare men, women and children all together is if the parts of the women match up. At the moment, women are 3 parts in one ratio but 7 parts in the other. So I've got men to women being 5 to 3, but in the second ratio, women to children being 7 to 4. So we need to think of some common multiple of 3 and 7 that we could change the women into so that they were both the same. And that common multiple is good as 21. So if I want to make both those 21, the first ratio needs timesing by 7 for every part, whereas the second ratio needs multiplying by 3 for every part. So then I have 35 parts men and 12 parts children. So now that these match for the women, I can combine it into one single ratio, men to women to children, knowing that I have 21 women in both. So children is 12 and men is 35. And then Megan said that there's 3 times as many men as children. So if there were 3 times as many children, we'd have to do 12 times 3 to find out what that should be. So 12 multiplied by 3 is 36, but actually we only have 35 men. So therefore, no, she is incorrect. Okay, obviously we could explain further if we wanted to and say that actually there are less men than 3 times the number of children.